Okay, good day, class. All right, so we have learned about circles, right? The standard form and general form of the equation of circle. Remember it, okay? Then we have discussed about the chord of the circle and the tangent of the circle. All right. All right. So today we will go to 5.1.1.3 intersection of two curves. All right. So means that to find the intersection of two circles. All right, so let's say consider that we have two circles, S1 and S2. All right, so this is the equation in general formula. This is the equation for S1, so name it equation 1. All right, and we know that the center is C1 and R1. Okay, for second circle, this is the equation. All right, G1 F1, then G2 F2 lah, C1 C2 lah. Okay, with the center C2 and R2. Alright, so to find the intersection point means we solve simultaneous equation, right? Okay, so to solve the simultaneous equation, we use 1 minus 2. Of course, you can use 2 minus 1, up to you, alright? So in my notes, I show that I use 1 minus 2. Okay? Alright, so this is how we solve. Alright, so you see that after we minus 1 minus 2, you see all the x squared and y squared disappeared. Alright, so you will get one linear equation. See? X plus y plus c. Alright, so you get a linear equation. Alright, so let's name it equation 3. Alright, so the intersection of two circles have 3 different cases. Alright, we will discuss one by one. Okay? Okay, so the first case is two circles intersect each other. Alright, so it is look like this. Okay, so the first one, two circles, case 1, two circles intersect each other. Means it's like this. You see, two circles intersect each other. Alright, this is circle 1 with center C1, second circle with center C2. So they intersect each other. Alright, so then equation 3 is the equation of the straight line which passes through the two intersection point. This equation, remember I said it is a linear equation, means it is a straight line. So where is this straight line? So if two circles are intersect each other, so this is a straight line. Alright, and you see that this straight line passes through the two intersection points. Alright, and we call it common chord. Alright, and the equation of this straight line is this one, the equation number 3 that we show here. Alright, and this is also the common chord for both circles. And when you solve simultaneously equation with equation 3 with 1 or 2, means after that we select x or y as the subject, then we sub into either one. Alright, then what will happen? You see, to find the coordinate of the intersection point. Okay, so solve simultaneous equation to find the intersection point. Then you will get a quadratic equations. Okay, you will get a quadratic equations with 2 different roots. Means your b squared minus 4ac must be positive. Okay, so means that when you sub 3 into either 1 or 2, you will get a quadratic equation with 2 different roots. Because 2 intersection points. Alright. And another characteristic is your C1, C2, the distance between two center will be smaller than R1 plus R2. Yes, of course, you see, this is C1, this is C2. So this distance definitely is shorter than your R1 plus R2, right? You see the red color one. So from C1 to the side, so it's R1. From C2 to the side is R2. So you see, when R1 plus R2 definitely longer than C1, C2, right? So you will get this condition. Alright, so let's say if the question give you 2 circles and let's say they ask you to prove that these 2 circles intersect each others at 2 different points. How to show it? So one of the way is you solve simultaneously and to find 2 roots. Alright, but if the question they will ask you to find the intersection roots, just want you to prove that they are intersect each other at 2 different points, then this is what you can do. Alright, so it means that from the equation of the circle, you find the center. Alright, so after you find the center, you find the distance between C1 and C2 by using the formula of distance. Then you add R1 and R2. Then if you can prove that this is shorter than this one, then yes, you can make your conclusion say that these two circles are intersect each other at two different points. All right, so this is the first case. All right, second case, case number 2 will be two circles touch each other. Not intersect at two different points, but they just touch each other. All right, so the way to solve the same, you are going to solve sub equation 3 in equation 3 will be the equation of the common tangent. This one, number 3. Just now is common chord. So second case will be like this. All right, they touch each other. So the equation 3 is the equation of a straight line, right? And this is a straight line. All right, it is a common tangent to both circles. Okay. Then when you solve simultaneously equation 3 with 1 or 2 to find the coordinates of the contact point, right? Just now is 2 intersection points. Now it's only 1 contact point. All right, so you will have 2 possible conditions. You will have 2 possible results. Okay, number 1, maybe you will get a quadratic equation also, but this quadratic equation will have 2 equal roots. Okay, means that you can have perfect square. All right, or you can check b square minus 4ac must be equal 0. Just now b square minus 4ac is positive, right? Now equals 0. All right, or you will just directly get a linear equation. Means either quadratic or linear to show that they touch each other. All right. Okay. And for case number 2, actually also have 2 different conditions for them to touch each other. They can touch each other externally like this, and they also can touch each other internally like this. See? So for number C1 here, so if they touch externally like this, then your distance for C1, C2 will be equals to R1 plus R2. Of course, C1 to C2 this is R1, this is R2, they must be equal if they touch externally. Okay, if they touch internally like this, all right, then your C1, C2 are very close, right? This is the small circle. C1 is the center for the small circle. C2 is the center for the big circle. So C1, C2 is very near only. All right, then you will find that C1, C2 will be R2 minus R1. R2, this one. The radius for second one, R2. R2 is this one minus R1. All right? Or R1 minus R2 lah. Depends which one is longer. Okay? So let's say if a question give you 2 equations of the circles and they want you to prove that they touch each other, either externally or internally. So how you can prove it? You can use this concept lah. Whatever which cases, you have to find the distance between C1 and C2. All right? Then you find either the sum of the radius or the difference of the radius. So if they are the same, then externally. Okay? If the C1, C2 same as the sum of the radius, then contact externally. If C1, C2 same as the difference of 2 radius, then it's touch each other internally. So this concept of C1, C2 and the radius is the one for you to prove it is which cases. All right? All right, so the third case will be do not touch each other. Do not intersect each other. Like this. 2 circles never touch or never intersect each other. So the equation 3 will be the equation of a straight line between 2 circles. Just like this. And when you solve simultaneously equation 3 into 1 or 2, then you will not give any solution. That you won't have any solution. Right? No matter what you get, after you sub in, okay, so you will get a quadratic equation, and the quadratic equation given to you will have no real roots. Means b squared minus 4ac less than 0 because no intersection point. All right, and to prove these third cases means they do not intersect with each other. Again, you need the distance for C1, C2, and the C1, C2 must be bigger than the sum of the radius. Because now C1, C2 is longer. Radius is only here and here. See? All right. So as a summary, so when you solve, when you are given 2 circles and we want to check whether they are intersect or not, so we have 3 different cases. right? Case 1 intersect each other 2 different points. All right, so C1, C2 less than R1 plus R2. Second, they touch each other. So for touching each other, you have externally or internally. If externally, C1, C2 same as R1 plus R2. If internally, C1, C2 same as different of 2 radius. All right, and the third case is 2 given circles are not touching or intersect each other. All right, then your C1, C2 will be bigger than R1 plus R2. Okay, so this is the part for 5.1.1.3. All right, so now we will see some examples. Okay, so example 5.1.1.3. Okay, so I'm going to discuss question 1 and 2. All right, so later you will do questions 3 as quiz. Okay, then I have 4 past year questions related to circles, or everything that you have learned about circles. There are 4 past year questions here. So I will discuss 1. So I will discuss question 2 lah, STPM 2007. So you will do question 1 as your quiz. So today lesson you have 2 quiz, 2 questions in the quiz. All right, and question 3 and 4 you will do as homework. Right? Okay, so let's look at question 1. Find the common chord of the 2 circles with the equation. So you are given the equation of 2 circles. Find the common chord. So if the question say find the common chord, right? Can you see? All right. So if the question say find the common chord, so means that they intersect each other like this. Case 1. All right. They want you to find this common chord. So as I say, very simple. This is question 1. So you are given these 2 equations. The equation of the circle. So equation 1, equation 2. All right. Then again 2 minus 1. I use 2 minus 1. So x squared minus x squared no more. Y squared minus y squared no more. So 1x minus negative 3x, 4x. Negative 3y minus 13y, negative 16y. This is 0, right? 0 minus negative 48, positive 48. All right. So you see, you get a linear equation. So I divided the whole equation by 4 lah. So you get a linear equation. So this is the equation for the chord. The question asks for equation of the chord. So you can stop here. I express the linear equation in general form. Remember, you can express in general form or gradient form. So I left it in the general form. All right, second question. You are given that 2 circles have equation. So you are given the equation of 2 circles. Show that the 2 circles touch each other and find their contact point. Touch each other. So means second case. All right. So they never ask you to show whether touch externally or internally lah. They just say show that they touch each other. Then find the point. All right. So again, same. This is the same step. Equation 1, equation 2 for the both circles. Then now I use 1 minus 2 lah, because I see negative ma. I use 1 minus 2. So x squared minus x squared no more. Y squared minus y squared no more. 2x minus negative 16x, 18x. Negative 8 minus negative 80, 72. Okay, so you see you get a linear equation again. And this linear equation is only in x. So after I solve it, I found that x equals to negative 4. All right, now you can make conclusion. I have only 1 contact point. Only 1. Therefore, the 2 circles touch each other. See? Then next, they want you to find the intersection point, right? So I sub x equals negative 4 into either 1 or 2. Either 1, up to you. I sub it into 1. X equals negative 4. So negative 4 square is 16. Alright? This one negative 8. So negative 8, negative 8, negative 16. So 16 minus 16, 0. So y squared equals 0. Y is equals 0. Therefore, the contact point is negative 4y. It's just that simple. So for this example, we have first one, chord means they intersect each other. Second question, they touch each other. All right. Until here, we do not know they touch internally or externally. We just find the contact point. If you want to go further, to see whether they touch internally or externally, then what you should do? Remember? Then you have to check your C1, C2 and your R1, R2. You have to check this one and see whether they touch externally or internally, right? But this question never asked, so we just leave it. Okay? So later, as I say, you do question 3 as a quiz, so we will see. You're asking to show that the two circles with the equation given touch each other externally. Touch each other externally. They never ask you to find the contact point or the equation. So you don't have to solve equation. You don't have to do this step for this question. They just wanted to show that they touch each other externally. So means this one, you have to prove this one. Okay? So you rearrange these two equations in general form. Remember the 2gx and 2fy form? You arrange in that form so that you can find the center of the two equations and calculate the radius of the two equations. Alright, so after you got that, you calculate C1, C2, then you calculate R1 plus R2, see whether they are the same or the same with this one. Okay, then from there you make conclusion. Alright, so question 3, you don't have to solve this thing because they never ask the equation of the line and they never ask you to find the intersection point. Okay, alright, so next will be the STPM question. So as I say, I will discuss question 2. Alright, so you will do question 1 as quiz. So I will go through the question with you so that you have an idea how to do it. Okay, so this is STPM 2010. And you are given that a circle C1, alright, this circle C1 passes through 3 points. So they give you 3 points. So find the equation of C1. This one we have learned before. Remember? They give you 3 points. Alright, so you use the general form. The 2gy, 2gx, 2fy and plus c, the one. Then you sub all the 3 points, then you get 3 linear equations and solve simultaneous equation, remember? To find g, f and c. Then you can get the equation of the circle, 4 marks. Alright, B, determine the coordinate of the center and radius. Alright, so if you have it in general form, no problem for you to find the center and radius. Or if you want, you can directly express this one in standard form. So directly you can answer this. Okay? Okay, part C. Now you are given another circle. Alright, so this circle they give you in standard form. Okay, B, find the distance between the center of two circles. Okay, so just now C1 you have the center already. This is C2, so no problem for you to find the center, right? So you have C1 and C2, calculate the distance. Alright, and then number 2, find the coordinate of the point of intersection of C1 and C2. This one you have to go through the step. Okay, something like this. You have to solve simultaneous and see how many intersection point. Alright, the coordinate, but from the question actually roughly you know, you see, find the coordinates of the point of intersection, means 1 point only. Okay, so it's not difficult for this question, alright, so you do it as quiz. Okay, and question 3 and 4 as homework. So I explain first before I go to this one. So question 3, you see, STPM 2006. So you are given one equation in general form. So you are asking to show that this equation is the equation of a circle with center A, B and radius this one. So this is your answer. Show that. Alright, so what you can do is, since you are already given center and also radius, alright, you sub center and radius into standard form. Alright, then you expand the quadratic. Okay, you expand it and rearrange, then your answer should be this one. Okay, your answer should get this thing. So once you get this one, then you can say it is a circle. Because you sub the center and the radius into the standard form of a circle. Alright. Then second one will be, this is a little bit complicated only. Alright, so you can do it. Okay, now you see the figure shows 3 circles, C1, C2 and C3. Alright, you are given 3 circles. C1 is the smallest one, C2 is the medium one, and C3 is the biggest one. Alright, you see C1 and C2 touch each other, and C1, C3, C2, C3 also touch each other. Touch only. Okay, where their center lies on a straight line. Okay, means that the center of this tree The center of these three circles, they lies on the same straight line. Means like this. So this is center for the smallest. All right. I use different color pen. Okay. So this is the center for the C2. Okay, where the center of the biggest one is here. Okay. Okay. So this is center for 1, center for 2, center for 3. They lies on the same straight line, the question said. Alright, so if C1 and C2 have this equation, so they give the equation for C1 and C2. Alright, then find the equation of C3. Okay, so we know that to find the equation of a circle, you need two things. One, the radius, and two, the center, right? When you have a radius and the center of the circles, then you can find the equation already, right? Okay, now the problem is how to find R3 and C3. Radius, no problem. Okay, so how to find radius of this big circle? Very simple. Because this is given, right? So when this is given, you please rearrange it so that you get the center and the radius for these two circles. Okay, so you have the radius for C1. Alright, and you have the radius for C2. Okay, when you have radius, you can calculate the diameter, right? The diameter for C1 is 2R1. The diameter for C2 is 2R2. So when you add the diameter for C1 and C2, it's actually the diameter for C3, right? Okay, it's the diameter for C3. Alright, so half of the diameter will be the radius of C3. So you find the radius already. Okay? Next is how to find center. How to find this center? Okay, so to find this center, alright, we are going to use the formula for the ratios. The ratios, this one. Okay, you look back to this one, first page. Okay, go back to first page. This formula, this one. The point divides the line joining 2 points, the lambda and mu. You use this one. Okay, how to use this one? Alright, so I show it here maybe. I draw out the line. I draw out the line. I enlarge it and make it bigger. Okay, so let's say this is the center of C1. So let's say I name it A . Alright, and this is the center of C2 here. I name it B . Okay, now I'm talking about these two only, from here to here only. Okay, so what is the radius? I'll let you know . The radius for C1 is actually 1 unit. Alright, and the radius for C2 is actually 4 units. Okay, so and this is 5. Remember that the radius for C1 is 1, so diameter is 2 . The radius for C2 is 4, so diameter is 8. Alright, diameter is 8. Okay, so if diameter is 8, so 2 plus 8, 10. Alright, so the radius for the biggest circle is actually 5. Alright, so this is 1. This is 5. Radius is 5. Okay, so it is in the ratio of 1 to 4. Because this is 4. Correct. This is 4, this is 1. From here to here is 4. 2. 4. Okay. Hold on, huh? Okay, correct. All right. So you see, you see, this is one, this is one. Okay, and we know that this the radius, just now I told you, right, the radius of the biggest is 5. 5. If here is 1 1, then means here is 3, correct? Because this is the total should be 5. So 1 1 3. All right, and we know that just now I told you also the radius for C2 is 4. From here to here is 4. So if here already 3, that means here is 1 lah. Okay, I mean my drawing is not follow the skill lah, but you know that. So you see, therefore this is A, this is B, this is A, this is B. All right, let's name this one D lah. Let's name this one D. Okay, D is the center. So A is the center for smaller circle, B is the center for second one, and D is the center for the biggest one. So it is in this ratio. All right, so just now you see lah. Between B and C is 1 portion. And for D to A is 3 plus 1, 4 portion. Yes, this is the lambda and mu. Alright, so you have the center already, center for the C1, center for C2 you have. So you, by using the formula for ratio, so you can calculate your D lah, the center. So you have radius and center, so you can form the equation. So I want you to try this one as homework. Okay, question 4 is STPM 2005. This is not difficult also. So you're asking to find the perpendicular distance from the center of this circle to this straight line. Alright, so maybe I can show you the diagram. So means that you have a circle. So they want you to find the perpendicular distance from the center to a straight line. So this straight line is 3x plus 4y equals 28. They never say this is tangent. They just say this is a line outside the circle. So find the perpendicular distance. So perpendicular distance means shorter distance, right? So you have the formula for shorter distance D, right? So after you get this, hence means from your answer, from this one, the perpendicular distance, find the shorter distance between the circle and the straight line. So what is the shorter distance between the circle and the straight line? This is the circle, right? So the shorter distance between the circle with the straight line is this one. Alright? So how to calculate this? So just now you already have this. Perpendicular distance from a point to a straight line. You already have this. Alright? So this is radius, right? So you find your radius from the circle lah. Okay? So the perpendicular distance minus the radius will be the shorter distance between the circle to the line. Alright, so you do this as homework. Okay, now I will go to question number 2. This is a little bit different compared to others, but actually we are using the concept of locus also. So as I say, remember you have learned locus. Okay, so this is the solution. Let's see. Alright, can see. Why suddenly cannot see? Alright, okay. Can Alright. Okay, so this is STPM 2007. Alright, so you are given that the coordinates of point P and Q are this one. So means P and Q, they are moving point lah. That's why they express in XY. This is small letter XY. Where X not 0, Y also not 0 lah. Then if Q moves on a circle with center 1 1 and radius 3, Q move on this circle. Alright, so I sketch. This is the circle that Q move on. So this circle is the locus of point Q lah. So Q move on this circle with center 1 1 and the radius 3. Okay. So next they want you to find what? Show that the locus of point P is also a circle. So means point P also moving, and the locus for the P is also another circle. Alright? So find the coordinates of the center and radius of the circle. After you have shown that it is a circle, find the center and the radius of the locus of P. Alright? Okay, so you see, P, the coordinate for P is XY. So I need to find the locus of P in terms of small x and small y also. All right, in terms of small x and small y also, but they only give us the information about q. All right, okay, so this is circle for q. Okay, with the x coordinate and y coordinate like this, so in small letter, so means that we are going to use this one to find another equation in terms of small x and small y. Okay, but before this, because too many terms, right, I make it simple first. Okay, let's say the coordinate for point q is capital X and capital Y. This capital X equals to this one, capital Y equals to this one. I use the big one first, easier to calculate. All right, then I sub this coordinate xy into the standard form of the circle. So the standard form of this circle in big X and big Y is x minus 1 because center square plus y minus 1 and equals to r square, right? 3 square. Okay, then I expand it into general form. I expand the x minus 1 square and the y minus 1 square. So this is 9. So I rearrange it. So x square minus 2x, y square minus 2y. 1 plus 1 is 2. 2 shift here become 7. Alright, so this is the standard form for this one. And now only I sub back my big X and big Y. So my big X is this one, right? So sub in. And my big Y is this one. So I sub in. Alright. Okay, so you see, this one you have square. This one you have square. Okay, so they have same denominator. X square plus Y square and square. So same denominator. So X square plus y square. So I group them. So this one and this one, I group, become one here. Okay, whereas this one and this one, they have same denominator also, x square plus y square, but no square outside lah. So I also group them. So I see minus minus so I factorize as minus. So it's 2x plus 2y lah. I factorize as minus. Okay. Now I multiply the whole equation. I multiply the whole equation by x squared plus y squared and square. I don't expand first, you know, when I expand, I know that it involves x power 4. It's like very complicated. I simplify them first. Okay, so I multiply the whole equation by this. Okay, so the first time multiplied with this, so simplify, right? Simplify. So left x squared plus y squared. Okay, minus. So I factorize out the 2. I factorize out the 2, become x plus y. And because I have 1x squared plus y squared, so multiply with this one, I simplify 1. So left 1. Alright, so 2x plus y multiplied with x squared plus y squared. Okay, then 7 multiplied with this whole thing. Okay. Alright, so the next step, I actually don't want this one. Because remember, I want to find locus P. Means I want to find one equation in terms of small x and small y. So it's already in small x and small y. And I know that the equation of a center don't have power 4. That's why I don't want the power 4. So what I can do is, now I divide the whole equation by x squared plus y squared. So that I eliminate the power, this one. I don't want power 4. Alright, so I divided the whole thing by x squared plus y squared. Alright, so this term, I assume this is one term. So when this x squared plus y squared divide x squared plus y squared, left 1 now. Alright, so this is second term. So when this second term divide by this one, divide, so simplify this one. So left this one only. Okay, and when this one divided by this one, so simplify 1. So left this. Okay? Alright, Anak? Can see, Okay, I move up a bit. Alright, now you see one equation in x and y only. Okay? So next will be 7, I shift it here. Okay, 7, I actually shift it here. So divide 7. So left x squared plus y squared. Remember just I said divide 7? Divide 7. So this is negative 2 over 7x. Minus so shift here, plus Then negative 2 over 7y Right? Shift here, plus this is also 1 over 7 The 7 move here and divided by 7 Okay, so positive 1 over 7, shift here, minus 1 over 7. So you see, I can find one equation in small x and small y. And I already proved this is actually the general form of a circle. So I proved that the locus for point P is also a circle. Alright? Remember, point P, the coordinate is small x, small y. So if I can get one equation in small x and small y, so this equation is actually the locus of P. Alright, and this equation also the general form of a circle. So I can prove that the locus of P is a circle. Alright? Okay, then next they want you to find the center and radius, right? Since we already have it in general form, so since we already have it in general form, so I express it in 2gx and 2fy form lah. Okay? So this is your g, this is your f. Therefore, center is negative g, negative f, right? So negative 1 over 7, negative 1 over 7. This is the center of the circle of locus P. And the radius is f squared plus g squared minus c. Minus c. Okay, so you get square root 9 over 49. So the radius is 3 over 7. Alright, so this is STPM question for 2007. Alright, so the only special thing is the concept of locus lah. So have the concept that if you are given a moving point, xy, then the locus of this moving point should be in xy also. So this Q, I assume that it's in big X and big Y. So I can use big X and big Y to form the equation of the locus of Q. Then only I submit. That you are given the x coordinate for the circle Q is this one. The y coordinate for the circle Q is this one. In terms of here, you see. So when I sub it, I can find another equation in small x and small y. You see, they never give you the locus for y, right? They never give you the locus for y, for Q, sorry. They only give you the coordinate. So if you want to find the locus of Q, this is the equation of the circle of Q. Okay, so we will stop here for today. Not too many questions lah. So I really hope that you can finish everything by today. So tomorrow we will go to ellipse. Alright, so tomorrow Friday is the actual class for Max T, right? 2 hours. So tomorrow lesson will be longer. Okay? So tomorrow we will start the actual conics, the first conic ellipse. Okay? Alright, thank you class.